drawing the CT lesions, right, in sort of this more blobby method, right, while our MRI sequences with the Wimbledon Plus method were a little bit more fine-grained. And so to deal with this sort of discrepancy between the two, I think initially the script went ahead and increased the lesion map slightly before it now performed the work. I'm not sure that that's true in the current image. I'm not sure that it does that it's a step in the current script.
So does that, I mean, the pushback, does that mean that in those days the Wimbledon method was more accurate?
I don't know that the Wimbledon method was more accurate.
Wimbledon Plus systematically increased the lesion volume.
Even that was to account for branch
systematically increasing on the CTs. I mean, and I mean, really, basically.
For the MRs, that perhaps the Wimbledon was better back then.
I mean, you know, this increase was along the edges of the lesion.
The reason that's important is that's often where we had poor coverage, the edges. Right, I mean, that would have, so increasing the lesion would systematically over 80 subjects would improve our coverage.
By 1 or 2 voxels?
Just 1 or 2 voxels.
Yeah, it's only by one. It was systematic.
I think it was not sort of systematically around the edges. I think it was particularly, true in certain areas, for example, in the temporal lobe, as opposed to seeing that in the frontal area. So I don't think there was a uniform
It was a temporal hole, though.
So I don't know about that. Yeah, whether that I doubt that that's the explanation for the differences we saw. But you don't think that your inclination, Dan, would be to attribute it to different strategies of tracing the lesions as opposed to something that systematically is introduced by the warping?
No, this was not. I'm more than positive this was not introduced by the warp as much as.
That just the process doesn't stretch.
Yeah.
The liability between our lesion traces, though.
Well, we did, but that was a moving target. We had reliability way back, right, when we first started this. But the lesion, I mean, as we were talking about before, the approach to tracing lesions has really changed. So who knows about the reliability of this now?
There are a couple of things that we did in the old script that I know. One is we did increase the size of the lesion just for masking. We never used that increased masking we don't use. But the other thing is when you work a lesion, you start off with 0s and 1s, and you end up with continuous values between 0 and 1 everywhere. And you have to decide where the cutoff is for what you're going to consider lesion or not lesion. And it's possible we've adjusted that cutoff historically. I don't know.
No, I don't think we. Yeah, it's always been.
But that is a place where.
Yeah, sorry, I was just going to say. So I thought the increased lesion mass that you were just talking about was actually applied.
It was only for lesion mass, for cost function.
Cost function masking. Okay, so that's what I was talking about. I thought that was also applied to the output of. Okay, so there you go.
Well, that's what I'm talking about, these continuous values.
Yeah. Yes. Yeah.
We did a program, by the way, because we are doing this Wimbledon when we talk evaluation. Yeah. And there's a little program as part of voxel. You can try it out if you like, although only I know how to work it.
Very good.
It's not that hard to use. Like I could just show you a configuration file you could try. That actually will take 2 drawings of the same lesion. I mean, it doesn't have to be, but that would be a sensible way to use it. Take the discrepancy map, basically all the voxels that are in this lesion, not that one, and vice versa. Divide them up into contiguous segments or pieces, fragments, I call them. And then present them to a rater one at a time in random order, and ask if you think this is part of the lesion or not. This is our best attempt to sort of adjudicate these methods, looking at these medical strategies. So we did that with a set of 4, I think, Wimbledon plus lines, and this branch of the radar. And the agreement was there was no clear winner.
And there wasn't a systematic bias to like sort of you
Well,
No.
systematically larger. Would you know that? Would you know
That
that?
we could find out more easily.
Yeah. Okay. So it would be nice to know that, just so that we could see whether it's still a concern that Laura and I had when we did this.
But if there is a systematic difference in size, it could result in a systematic difference in plausibility to
And so, the last step is, right, you actually apply the warp to the lesion mask itself. And so this basically is our normalized mask to fit on column.
So what it does is it takes those same parameters, right, that were used in warping the brain,
Yes.
and applies it to this area that was now masked out. Is that
It
right?
applies it to the mask, the lesion tracing that we drew.
Okay.
And in essence, that's what this is, right? So we can now overlay this on top of column. It's now in M&I space. And it's tried to basically account for that adjustment that Branch has to make for the CT scans or the Wimbledon method, right, where you're trying to say, well, this is colon, how big is this part of the lesion versus this part of the lesion? That's sort of taking it.
And that's right.
Yeah.
So that's what branch.
Yes.
Right.
And then
for every warp branch looks through and
Yeah.
hand checks it and touches up where it needs to be. And that's another place where he hasn't ever said anything about kind of systematically enlarged results. So
Yeah. And I have to say, overall, from these outputs, I think he's touched up one.
yeah, and he's been pleasantly surprised because he was very skeptical at the outset about whether this would work. There's been a big transformation in Branch's attitude about this as he's looked at these.
So you think it's still worthwhile that we have that checking at that last stage?
Yeah, you definitely do want to check at the last stage. Do you how well do you think this?
2 months, year,
Yeah.
Yeah, I mean, it's practically, it becomes a big issue.
Yeah.
If we still feel that
Yeah, I do think that it is still important to check to give that last check. But I mean, I tend to put more weight in the transformations in these transformations because essentially it's applying that same math to the mask itself. So if this looks pretty good, chances are this is going to be pretty good as well.
What do you do if it looks bad?
If it looks bad, after the crying stops, you start messing with the parameters that we talked about, right, previously, where you start to change the number of iterations. Here we go. You start to change these numbers, right? The number of iterations that you're running. You can also change this guy, the radius, for the metric that you're determining.
And it could look bad on a case-by-case basis. I mean, you might have to do these tweaking. You
Yeah.
might have to do it case-by-case just by virtue of the peculiar
Nature of each individual person, exactly, signal in each person's brain, yeah. But overall, I have to say, 80% of the time, it's you run the script, it outputs, you look at it, and most of the time I've been happy with the outputs using the parameters that we
There
have.
are actually two distinct kinds of bad. One kind of bad is catastrophic bad. Catastrophic bad almost invariably means that the affine portion of transformation has gone wrong. The affine portion comes first.
Yeah.
And there's a check. The ants.sh script, I believe you might have one of the files there. It produces an affine transform file in that directory. You can eyeball to see if it looks like it's kind of colonist, if it at least looks like it's going in the right direction. And so normally when there's a catastrophic error, you'll see that has gone terribly wrong, and that's the answer. It's when you get these subtle, like these weirdly deep in sulci or some sort of like the tip of some virus is folded over into another virus to do that kind of thing.
Yeah.
You want to sort of play with the parameters of it.
And is the planks, is this way, don't try this at home, seek professional help, or, I mean, there's a lot of parameters that,
a little bit of it is that, but I mean, I would at first pass go ahead and try changing, like I said, the iterations, right? But Yeah, usually, I mean, I think with this script, it's fully expected that it's going to be an email or a call saying, hey, what do I do?
And each of these takes 1 to 2 hours.
Yes, down from 8 in the original. Like,
Lately it's been going more like 45 minutes.
okay.
It doesn't take that long.
All right.
That is
So
the whole
improvements
the
to,
full sequence from beginning to end, or each?
yeah,
Oh,
the
yeah.
full
Is
sequence.
that on our cluster or the?
I was going to say the CFN cluster has improved over the last couple of years, so that has.
It's not-
Also,
it's not
ANTS
the
has
question.
improved.
Definitely makes changes in the code. It's this
ANTS,
program itself,
but used to.
The program to apply the transformation takes no time at all.
Is that it's
Has anyone tried this on our system?
We're waiting for you, Steve.
Okay.
You're the guy.
Yeah, the fact that ANTS is not installed on all the virtual machine means I might have forgotten to put it on the cluster.
Oh, no.
I'll try to fix it. I saw that.
Exactly. So I thought it was installed there this morning, and I was like, oh, it's not. Okay. I'll have to work past that. But I don't know that it's on the cluster here. I haven't tried to log in here, so we'll see.
AND program actually distributes its iteration component? I don't think so. Or even brain, it's just used one machine, right?
Yeah, one CPU.
It will not,
I mean, but you can use the VB batch command, right? Which comes in voxel, which will now, as long as there's multiple computers, it will sort of send it to the different CPUs.
Right, but, this AND command,
One normalization, yes,
brain, so
exactly.
you know.
So yeah, there's no sort of components that it can break up to do it. This is just another example of another warp that I have. So this is one, I think Grant showed this similar image, right? So this is one where we have this, fair amount of distortion in the scan. We're trying to get to Colin, and this is one that sort of failed sort of spectacular fashion, right? It replicated the distortion effect, right? Straight of course. Yes, so this is one where, yes, there was a lot of crying and tears, and it was like, oh my God.
Registration is something actually went pretty well.
Yes, exactly. So, despite the distortion, the registration itself was pretty good.
Playing with the different the number of iterations, the various parameters, is there any reason to think that this tweaking and playing around with can somehow influence our final product or our final data? And to what degree?
I mean, well, yes.
I know that's the overarching question, but I mean, I know you say maybe 20% you have these issues or whatnot. And so that's a large percent when you're thinking about your data and looking at the actual data itself. So I'm kind of wondering, how safe is it to be playing around these iterations?
I would put good money on it doesn't really matter.
Yeah.
I also would put good money on it doesn't really matter all the work that Grant does getting these equations exactly right. Because the only thing that ultimately matters when you're doing a VLSM analysis is if it moves the border of a lesion to somewhere else. And every time you move the border of a lesion to somewhere else, it's making a change in one subject in two different little chunks. So unless you have some sort of systematic thing that's going to move that same border in the same direction to more than one subject,
right?
In a way that also correlates with your task, it's really unlikely to matter that much.
But you're talking about mattering in terms of introducing bias in the results, right? The other way of mattering is that you just have you're introducing noise, and so you can't see what you should be able to do.
That's what I'm saying.
Yeah, but I guess when you compare,
so coarse here that it doesn't matter so much if you're just shifting it in such a small way with one person in one fashion.
Yeah.
And of course, if you have 10 subjects and you're moving one of your subjects,
right.
6 voxels.
yeah.
I think if the behavior of interest should map onto a region at the edge, at the border of a lesion, that's where you might run into more problems. Right. So you have lower power there. You probably have poorer coverage there to begin with. So you probably have fewer subjects. And then, so these any biases and noise at the edge might screw up your ability to see.
But all you're really doing, when you move that border, you're probably not creating or destroying a region. What you're probably really doing is making one of your region chunks bigger and making one of them a little smaller. And you already know with Bayesian analysis that the spatial coherence of the map is very high. Lesions